Okay, this is the 2.7 video with extra examples over the ones that we skipped in class. So I'm scrolling down. The first type that we talked about in 2.7 was quadratic and polynomial inequalities, and we did not do D or E, so I'm going to go through those real quick, and then I will talk a little bit more about the rational inequalities. So for D, we have this, remember the idea that we have to get this with a 0 on one side. So the first thing we would need to do is to move over the 9. So if we subtract that over, we're going to get 16x squared minus 9 is greater than 0. So then we can factor this using perfect square method. So this would be 4x plus 3 and 4x minus 3 greater than 0. Our critical values would be 4x plus 3 equals 0, 4x minus 3 equals 0, which gives me x's of negative 3/4 and positive 3/4. So then we would put that on a number line. Remember, this is our next step using the chart method. From least to greatest would be negative 3/4 and then 3/4, being positive. We're dealing with a greater than, not equal to, so this is going to be open circles. And then this would be negative infinity to negative 3/4 with a parentheses, negative 3/4 to positive 3/4 with a parentheses, and 3/4 to positive infinity. Test values, smaller than negative 3/4, I'm going to use negative 2. In the middle between negative 3/4 and positive 3/4 would be 0, and bigger than 3/4 I'm going to use positive 2. My factors are 4x plus 3 and 4x minus 3, and we want to know if we multiplied those together what would be the overall sign, and we want our sign to be greater than 0, so we're looking for positives. So negative 2 times 4 is negative 8, plus 3 would be negative 5, so that's negative. Negative 2 times 4 is negative 8, minus 3 would be negative 11, so that's also negative. A negative times a negative makes a positive. 0 times 4 is 0, plus 3 is positive 3. 0 times 4 is 0, minus 3 is negative 3. 2 times 4 is 8. 8 plus 3 is positive 11. 2 times 4 is 8, minus 3 would be positive 5. Positive times negative is negative. Positive times positive is positive. We wanted the plus sign. Oops, not letting me do that. Hang on. Because we wanted greater than 0. So notice I'm highlighting those as my two intervals that work. So my solution for this one would be negative infinity to negative 3/4 unioned with 3/4 to positive infinity. Okay, let's look at E. Again, move the 16 over first, so we have this less than 0. Okay, for this scenario, we need to factor this. This has got x squared in the middle, so we're going to try to factor it with x squared and x squared. So factors of negative 16 that make positive 15 would be positive 16 and negative 1. Now, this one is actually prime and does not give us anything for our critical values. The reason for that is the only way to factor x squared plus 16 is to actually have imaginary numbers for critical values, and we don't. All of our critical values are going to be real numbers. So since this factors imaginary numbers because of the plus there between the two perfect squares, this gives us no critical values. But this one factors again. So I'm just going to bring down x squared plus 16, and then I'm going to split this other one into x minus 1 and x plus 1. So even though there's 3 factors here, there's only 2 critical values. So this would be a -1 and a +1. I'm not writing them in the right order, but that's what we get from these 2 pieces. Now, when you do make your chart, you don't want to leave off the x squared plus 16 because it is still a factor. And after we finish solving this one, I'll show you on Desmos why this graph has this extra piece that doesn't give us a critical value, because graphically this makes sense, but unless you know that already, you don't see what's happening. So this is -1 and 1. And our intervals, these are less than, so not equal to, so they're going to both be open on the endpoints. So open circle, open circle. This would be -infinity to -1, and -1 to 1, and 1 to infinity. My test values, I'm going to use -2, 0, and 2 because they fall in each of the individual intervals. And when I go to write my factors, I do include the x squared plus 16. It doesn't really affect anything because when you plug anything into this and you square it and then you add 16, it's going to stay positive, but it's good to not leave factors out because what if it was a bit a negative and then you would get the wrong answer. So this would be less than 0, which means we are looking for negatives. So -2 squared is positive, plus 16 would still be positive. 0 squared is 0, plus 16 is positive. 2 squared is 4, plus 16 is positive. So no matter what you plug into this first factor, it always gets squared, which makes it positive, and you add 16 more to it, so it stays positive. -2 minus 1 is -3. -2 plus 1 is -1. 2 negatives make an overall positive. 0 minus 1 is negative, 0 plus 1 is positive, 1 negative would be negative. 2 minus 1 is positive, 2 plus 1 is positive. So 3 positives make a positive. We wanted less than 0, so there's only one interval that works in the real numbers, which is -1 to 1. Now let's actually show you graphically what happened with this because I think it's interesting. So let's go to Desmos. So I want to start graphing. And remember, I'm going to enter it in after I've already solved it for 0. So y equals x to the 4th plus 15x squared minus 16. And then right here, we get that we wanted y to equal 0. So notice that this still only crosses the x-axis twice at -1 and 1. What happens with x to the 4th is that it ends up starting to look like a parabola. So I'm going to zoom in down here on the end. Actually, I'm going to zoom out a little more. See, it looks like a parabola. It just goes up forever. So that other factor, that x squared plus 16, it does not give you any x-intercepts because the solution to that is an imaginary number. So I just wanted you to see that, you know, sometimes the factors don't come out with real numbers and the only critical values that count are the ones that are real numbers. All right, so I'm going to minimize that. That takes care of the polynomial ones because we did F in class. So now we're going to look at a few more rationals. I'm going to look at these beginning ones because we didn't cover them in class because they were already mostly factored. So for this first one right here, it does have a little bit of factoring to do. So we're going to leave this. X squared plus 1 does not factor. It's going to be another part where you're going to have imaginary pieces, okay, because it's not factorable, and we learned that perfect squares with a plus were imaginary, really. We have this x minus 3. On the bottom, we have an x plus 3 and an x minus 3. Now, do not cancel out the x minus 3's. If you do that, you lose a critical value because this is a 3 and it does show up on both top and bottom. So when we do our critical values, we list what do we get from the top and what do we get from the bottom when you're doing a rational. So x squared plus 1 is x squared equals -1, which we just said a minute ago is imaginary, not a critical value. So that's just a side note for that guy. Whoops. So that's why I'm not going to be doing anything with the x squared plus 1 in terms of finding critical values. Okay, but we do need to set the x minus 3 equal to 0. So that would be x equals 3. For the bottom, we have an x plus 3 equals 0 and an x minus 3 equals 0. That gives me negative 3 and 3. This is the first time this has happened, so I want to point this out. The number we have for the top is the same as the number we have for the bottom on one part. If you had canceled that out, you would miss this, and this is not something you can miss because it does cause an issue. If you plugged in 3 into this problem, you would get 0 over 0, which we don't even know how to handle yet. And it's undefined for us because of the 0 in the bottom. So when you're doing this type, notice we said that the top always obeys the greater than or equal to 0. It obeys this piece. But the bottom is always open. That was our little phrase that we kind of helped us to remember this. If a number appears in both top and bottom, this is the part that takes precedence. So these are both going to be open, and this guy is going to follow the rule of being open in the bottom. You can't be closed and open at the same time. So because dividing by 0 is worse than anything else, we go with it being open. So this would be negative 3 and 3. Our intervals are all going to be open, even though we had an equal to. The top only possibility had to be open because it also showed up in the bottom. So then my test values will be negative 4, 0, and 4. When you list out your factors, make sure you use all of the factors, even the x squared plus 1, the x minus 3, those are both from the top, the x plus 3, and the x minus 3. It is important that you list the factors as many times as they appear because one sign change will change the whole outlook. And then this is supposed to be greater than or equal to 0, so we're looking for pluses at the end. So negative 4 squared is 16, plus 1 is positive. Notice all of these end up being positive. Anytime you have a squared part plus a positive number, everything ends up being positive. Negative 4 minus 3 is negative. Negative 4 plus 3 is negative. Negative 4 minus 3 is negative. 3 negatives make a negative. 0 minus 3 is negative. 0 plus 3 is positive. 0 minus 3 is negative. 2 negatives make a positive. 4 minus 3 is positive. 4 plus 3 is positive. 4 minus 3 is positive. See, this is the first time that I've been able to show you one where you don't just get alternating signs. And we are looking for pluses, so we have 2 intervals back to back. Now, if this was a closed circle, we could just make this one big interval. But because this is open, we have to write it as 2 with a union. So that is what we get for that. So because that 3 showed up on top and bottom, it does create an empty hole there at that specific number, even though everything else from negative 3 up is true except for 3. All right, so that's what a case would look like if you have 2 of the same sign back to back. Let's look at this one. This is a squared on it, but it's actually not going to have a problem with being imaginary because x plus 3 could equal 0. So sometimes when I see stuff like this, I just go ahead and break it up and write it twice. That way I know exactly what I've got. This is 2 minus x. Then I have an x plus 4. And then I have an x plus 2, x minus 2 if I factor it all the way. So if you split it up and write each thing once, you get 6 total factors up here. Now for the top, you don't have to solve the same thing twice. It's going to be a value, but it's not something you have to solve twice. You just have to make sure you get the correct amount of them. So for this guy, we have x plus 3 equals 0 would give me a negative 3. And 2 minus x, you just add the x over, so x equals 2. For the bottom, x plus 4 equals 0 gives me negative 4, and x plus 2 equals 0 gives me negative 2, but x minus 2 equals 0 gives me another x equals 2. So again, because I have something that shows up twice, I'm going to highlight this here. And there is a reason for that. Okay, if something shows up twice, top and bottom, so one of each, you always go with it being open. So we're going to defer to this because it's in the bottom. These are also open because they came from the bottom. This guy is going to obey the less than or equal to symbol that we see because it's the only time it showed up was on top. It showed up twice, but it showed up on top only. So this one is going to be closed. So it's not always as easy as the whole top is closed and the whole bottom is open. If a number shows up in both locations, then we have this issue of it is going to defer to the bottom restriction. So let me get the chart set up and we'll go through this pretty quickly. So my smallest critical value of all is -4, then -3, then -2, and then +2. The only one that is closed is -3. Everything else either was in a denominator or showed up in a denominator and on top as well. So this would be -infinity to -4 parentheses, -4 with a parentheses to -3 with a bracket, -3 with a bracket to -2 with a parentheses, -2 to 2 both with parentheses, and 2 to infinity with parentheses. Test values, I have -5. Oh, I'm going to have to use a decimal here, so -3.5. Another decimal, -2.5. Just make sure it's in the interval. I can use 0 and I can use 3. I'm going to list out my 6 factors: x plus 3, x plus 3, 2 minus x plus 4, x plus 2, and x minus 2. I'm looking for an overall less than or equal to 0. I don't have a lot of room to write that, so looking for less than or equal to 0, which means I want negatives. -5 plus 3 is negative. -5 plus 3 is negative. 5 minus -5 is, or excuse me, 2 minus -5 is actually 2 plus 5, so that's +7. Be careful when the number comes first because that can mess you up. -5 plus 4 is negative. -5 plus 2 is negative. -5 minus 2 is negative. 1, 2, 3, 4, 5 negatives make a negative. So this one is going to be a solution. -3.5 plus 3 is -0.5. That happens again. 2 minus -3.5 is 2 plus 3.5, so that's positive. -3.5 plus 4 would be +0.5. -3.5 plus 2 is negative. -3.5 minus 2 is negative. 1, 2, 3, 4 negatives make a positive. -2.5 plus 3 is positive. Again, it's positive again because that's also x plus 3. 2 minus -2.5 is 2 plus 2.5, so that's positive. -2.5 plus 4 is positive. -2.5 plus 2 is negative. -2.5 minus 2 more is negative. 2 negatives make a positive. So notice I got 2 pluses back to back here, but we're in trouble because that is not what we want. We want negatives. So we are going to have to talk about this a second. 0 is going to be a positive. 2 minus 0 is positive, 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 and negative. You have to be careful with the 2 minus x because if you cover up the x, it's still a positive 2. So that's one negative, which makes it a negative, so that is good. And then 3 plus 3 is positive, positive. 2 minus 3 is negative. 3 plus 4 is 7. 3 plus 2 is 5. 3 minus 2 is positive. So positive, positive, negative, positive, positive, positive. So that makes a negative overall. So see, this is kind of interesting. We get a negative, 2 positives back to back, and then 2 negatives back to back. We want the negatives, which is why I have those circles, because we want less than or equal to 0. But when you have an answer with a closed circle, so notice I'm highlighting that there, the closed circle has to be included in your answer as either an interval or a single digit by itself. Because we were not looking for pluses, this closed circle is actually surrounded by two falses for us, because for us a true is a negative. So with this situation, we have to write our answer very carefully. So I highlighted all the answer pieces. So this is negative infinity to negative 4. Union, you want to go in order. If a point is only by itself, we put it in something called a set brace. So notice I'm doing squigglies instead of a parentheses. That means a single number works as a solution, but it does not show up as part of the interval. And then we also have negative 2 to 2 unioned with 2 to infinity. Because this one is kind of wild, I do want to show you graphically what it looks like. So let me get back to a graph real quick. Oh, it was on my other browser, sorry. There's Desmos. Okay, so we want to try to enter in this whole left side, which is kind of interesting. So I have, let me see, I'm going to need to create a fraction first. So notice that in Desmos you do have some symbol notations. And we want a fraction bar, so let me see. Oh, I don't have that here, but I think I can still create it by using the slash key. So I'm going to do extra parentheses here. So I have an x. Let me get back to my actual equation. X plus 3, 2 minus x on top. So x plus 3, and I could write that squared if I wanted to. And 2 minus x, that's from the top. Okay, there's my fraction bar. On the bottom, I have x plus 4. I also have an x plus 2 and an x minus 2. We would never ask you to graph this one to solve this, but I did want to show you something interesting about the problem. So let me close this part out. Okay, so let me show you this issue right here. So notice we have from negative infinity to negative 4 that this is below the x-axis. So that's to right here. So notice right here, trying to show you with my arrow, this is from negative infinity all the way to negative 4, and notice this whole red chunk is under the x-axis, which is blue right here. And then look what happens next. I'm above and above surrounding negative 3, which is our only actual part where we touch the x-axis here, okay? So notice this part right here, I'm above on the left side of it and I'm above on the right side, okay? Now, we also had critical values of negative 2 and 2. What this graph doesn't show very good is that negative 2 is right here, so that's this other part. I'm down below, but at positive 2, they don't show it on the picture here, this point actually doesn't exist. Okay, the graph on Desmos is not capturing that, but there should be an open circle right here because of it being in the denominator. So for us, we have this piece where we say, okay, it's still below, but there is this open circle right there. And that's all there is to that one. So I just wanted to make sure you guys saw the whole thing. This one's way more complicated than anything we would put on the test, but I wanted you to see a case where you get these pluses back to back and these minuses back to back and how that's, it's just showing you that there's some things going on there, okay? Okay, so we did C and D in class, so I'm going to skip on, actually no, we didn't do D. We did C in class. So let's skip down to D. Okay, so D needs to be factored first, so this would be 2x over 4 plus x and 4 minus x less than 0. Our top consists of 2x equal to 0, which would mean that we have 0 as a critical value this time. Our bottom is got a 4 plus x and a 4 minus x. On this one, I would just add the x over, so that's x equals 4. On this one, I would subtract the 4 over, so negative 4. In this case, the bottoms are always open. Remember, that's just our rule. And so is the top this time, because the top obeys this symbol. So this is also not got the equal to. So everything we're doing this time is open circles. So I would have negative 4, 0, which means I can't use 0 as a test value this time, and 4. So open, open, open. So I have negative infinity to negative 4, negative 4 to 0, 0 to 4, and 4 to infinity. Okay, so for this one right here, our factors are a 2x from the top. Oh wait, let's do our test values first, sorry. Skipped a step. I would use negative 5, negative 2, 2, and 5. Just make sure they're each in the interval above. So I need a 2x, a 4 plus x, and a 4 minus x. And I want an overall sign of less than 0, which means negative. So 2 times negative 5 is negative. 4 minus 5 would be negative. 4 minus negative 5 would be plus, so that's going to be positive. Two negatives make a positive. 2 times negative 2 is negative. 4 minus 2 is positive. 4 minus a negative 2 would be positive. One negative makes a negative. 2 times 2 is positive. 4 plus 2 is positive. 4 minus 2 is positive. 3 positives is positive. 2 times 5 is positive. 4 plus 5 is positive. 4 minus 5, though, is negative, so we get a negative. So we get two negative cases of negative 4 to 0, unioned with 4 to infinity. Okay, let's talk about E. We need to subtract the 4 over first. Do not try cross multiplying. This is not an equation. So if we subtract the 4 over, we could make that 4 over 1. Get a common denominator by multiplying the right part by the 3x plus 5. That would make this 3x plus 5 on the bottom. And I'm going to work over here to get the top. This is x minus 2 minus 4 times 3x plus 5. So x minus 2 minus 12x minus 20. And that would give me negative 11x minus 22 on the top. So for my top, I only have to worry about, and I wouldn't pull out that negative 11. It's just going to make it harder to do your chart. So add the 22 over and divide by negative 11. So negative 2 is my top critical value. My bottom critical value comes from the 3x plus 5, which if you solve that would make subtract 5 and divide by 3. So negative 5/3. So I go to make my little chart. And I need two lines, one for each. 3 goes into 5 once with some leftover, so that's actually negative 1 point something. So negative 2 is actually smaller. Sometimes you have to turn it into a decimal to see that. And then this is equal to, so the top, since it doesn't show up anywhere else, is going to be closed. And the bottom is always open. So negative infinity to negative 2 with a bracket. Negative 2 with a bracket to negative 5/3 with a parentheses, and negative 5/3 to infinity for the last interval. Test values, and I'm sorry about that, that keeps popping up. If you can see it, my husband is changing our Dropbox. So this would be negative 4, negative 2. This is, let's find out what that actually is, because we want to be careful not to pick something that's not in our interval. So 5 divided by 3, and it's negative, so negative 1.6. I would probably go with negative 1.8 just to be safe, because if this is about negative 1.67, we have to pick something between those two values. And bigger than this, since it's negative to a positive, I would go with 0. So then we plug into our two factors. And our overall sign needs to be less than or equal to 0, which is a negative. Ooh, ignore that slash. I don't know where that came from. So we want negative answers here. Now, negative 4 times negative 11 is positive 44. Minus 22 is going to be positive. 3 times negative 4 is negative 12, plus 5 is actually negative. So that's a positive times a negative, which is a negative. Negative 11 times negative 1.8, I don't know that off the top of my head, so I'm going to do it. So 11's negative times 1.8, which is also negative, is 19.8 minus 22. So we're actually taking away more than we have. So that's going to be negative. And 3 times negative 1.8 is negative 5.4, plus 5 is still going to be negative. So that's going to be positive overall when we divide. 0 is just going to leave me with negative 22 and a positive 5, so a negative overall. So we actually get two different intervals, negative infinity to negative 2 bracket union with negative 5/3 to infinity. Okay, F is similar to G that we did in class. Need to subtract over the fraction so that it joins the other one. Get a common denominator by multiplying this side by the x minus 5 and this side by the 2x plus 3 on both top and bottom. Work my stuff out over here on the side. 2x minus 5 minus 2 times 2x plus 3. That would be 2x minus 10 minus 4x minus 6. So my numerator is now going to be negative 2x minus 16. And I have two things in my denominator, 2x plus 3 and x minus 5. So my top critical value is negative 2x minus 16 equals 0. Add the 16 over, divide by negative 2. So that's negative 8. My bottom values are, I'm going to save a little space. This will be a positive 5 and then subtract 3, divide by 2. So negative 3/2. Bottom is always open, but the top obeys the symbol as long as it doesn't also show up in the bottom. So since negative 8 is only on top, it obeys the symbol and it is closed. So then we put these in order from least to greatest, just like always. And we have negative 8, and then negative 3/2, and then 5. The only one that is closed is negative 8. So negative infinity to negative 8 with a bracket. Negative 8 to negative 3/2 with a bracket on one side and a parentheses on the other. Negative 3/2 to 5, and 5 to infinity. My factors, well, let's do our test values. Test values would be, let's say, negative 9. This is not going positive, and that's negative 1.5, so I'm going to try negative 2. This does change signs, so I can use 0, and 5 to a positive infinity, we can use 6. So we have negative 2x minus 16, 2x plus 3, and x minus 5. And we hope our overall sign is less than or equal to 0, which is negative. So that would make positive 18 minus 16, so that's plus. Negative 9 times 2 is negative 18, plus 3 is negative. Negative 9 minus 5 is negative. Two negatives make a positive. Negative 2 times negative 2 is positive 4, minus 16 is negative 12. 2 times negative 2 is negative 4, plus 3 is negative 1. Negative 2 minus 5 is negative 7, so 3 negatives make a negative. 0 would cancel out all the x's, so we get negative, positive, negative, which is an overall positive. Negative 2 times 6 is negative 12, minus 16 is negative 28. 2 times 6 is 12, plus 3 is 15, so that's positive, and 6 minus 5 is positive. So that makes this one negative, which is an overall negative. So then we circle our regions that are negative since we want less than or equal to 0. and write our interval. Sorry, it takes it a minute to render. There we go. Okay, the final example is h, which has an x on top as well. What that usually means is you're going to get two factors on the top once you work this out, but you can still do it the same way we did the other one just now. So x over 2x minus 1, we're going to subtract this other fraction over. And then we need to get this guy to have the x plus 2 and this one to have the 2x minus 1 on both top and bottom. So my denominator now is 2x minus 1 and x plus 2. For the numerator, x times x plus 2 minus 3 times 2x minus 1. That's x squared plus 2x minus 6x plus 3. I'm going to go ahead and work this out. That's x squared minus 4x plus 3, and that factors into x minus 3 and x minus 1. So I worked out that numerator piece over here. Okay, so from the top, we're getting the following critical values, positive 3 and positive 1. I'm going to try to save a little time on this one. So that's just by setting those equal to 0. For the bottom, we're getting add 1 divide by 2, so that's a half, and negative 2. So then this has an equal to, so the top ones are going to be closed. Bottom is always open. So then we look at putting these on the number line. Negative 2 is the smallest, then 1/2, then positive 1, and then positive 3. So I have negative 2 is open, 1/2 is open, 1 is closed. It's not letting me draw that. And so is 3. For some reason my pencil's not working. Oh, that's because my whole thing shut down. Hang on just a second. Okay, I had to take a second and just kind of re-sketch out what I had written because it deleted it all. But we have negative infinity to negative 2 open, negative 2 to 1/2 open, 1/2 is open but 1 is closed, 1 to 3 is both closed, and 3 to infinity. Okay, so our pieces for our test values are, let's choose negative 3 because that's smaller than negative 2. This changes signs and I can use 0. 1/2 to 1 is not so great. I'll have to use like 1.7. Or no, 0.7, sorry. Because 1.7 is in the next interval, so you have to be careful. 0.7. 1 to 3 I would use 2, and bigger than 3 I would use 4. So I have x minus 3, x minus 1, 2x minus 1, x plus 2, and we want the whole overall sign to be greater than or equal to 0. So we have negative 3 minus 3 is negative, negative 3 minus 1 is negative, 2 times negative 3 is negative 6, minus 1 more is negative, negative 3 plus 2 is negative. 4 negatives make a positive, which is a good symbol because we want greater than 0. 0 would be negative, 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 and positive. 3 negatives make a negative. 0.7 minus 3 is negative. 0.7 minus 1 is negative. 2 times 0.7 would be 1.4. 1.4 minus 1 is actually positive, and 0.7 plus 2 is positive. 2 negatives make a positive. 2 minus 3 is negative. 2 minus 1 is positive. 2 times 2 is 4. Minus 1 would be positive, and 2 plus 2 is positive. So that has one negative. And then 4 minus 3 is positive, 4 minus 1 is positive, 2 times 4 is 8, minus 1 is positive, and 4 plus 2 is positive. Sorry, I'm trying not to talk too fast, but also get through these. So this would be negative infinity to negative 2 with a parentheses, union 1/2 to 1 with a bracket, union bracket 3 to infinity. Okay, that's the end of that piece, but before we completely cut this off and say we're done, I'm going to pull up 2.6 because we did skip something in 2.6, but I want to show you that you can solve it using this method. We skipped over the reciprocal property ones, but they really are something you can use the chart method with. So look at this first one right here. It already has the 0 on the side. The 3 is not got any critical values. There's no x there. So my only critical value comes from the bottom, which means it's going to be open, and it's this subtract 5 and divide by 2. So in this scenario, there's only one separator. So this is negative infinity to negative 5 over 2, and negative 5 over 2 to positive infinity. Test values, let's see, that's negative 2.5, so negative 3 and 0. Okay, those are my test values. And then I have a 3 on top. So this is what happens if you have a number. You just put it there. And then I have a 2x plus 5 on the bottom. And then this would be less than or equal to 0. So I'm looking for negatives. You can't make this change, so this is still positive 3, positive 3. This cannot be affected by those numbers. 2 times negative 3 is negative 6, plus 5 is negative 1. So this case comes out negative. 2 times 0 is 0, plus 5 is positive. So you'll see that this goes pretty quickly when you just have one thing going on in the bottom. So this would be negative infinity to negative 5/2. With this one, I would put that 3 on the top or the bottom. In fact, it might actually be easier to put it on the bottom. Let's do that. So this would be 3 over negative 2 plus x. You can't put it in both locations. You either choose to distribute to top or the bottom, because if you do it to both, you actually made the whole thing change signs, because negative over negative would be positive. So this would be 3 over x minus 2 if we want to rewrite that a little bit. So again, I have a bottom critical value but not a top one because there's no x up here. So this is going to be open, and it's x equals 2. So we would do our number line, put our 2 in the middle, so I can use 0 and let's say 3. I'm not going to show all my intervals because I'm just doing this pretty quick. And then 3 over x minus 2, and I want it to be less than 0. So this would be positive and positive for 3 since he can't change. 0 minus 2 is negative, 3 minus 2 is positive, and this one also works out to be the first interval. So this would be negative infinity to 2. For this last one, there's a problem. This is imaginary, which means this will always be positive. If you square something, it goes positive. If you add 4 more to it, it goes positive. And if you tried to solve this, this is not a critical value. You get x squared equals negative 4, and we know that's imaginary, which means it's not a critical value. Critical values for us in these problems have to be real numbers. So this is never going to be true, because if this is always positive and this is always positive, a positive over a positive is never less than 0. So this guy right here is just a special case. There is no solution. So that could happen either way. It could be no solution or it could be all real numbers. What you have to ask yourself is, does that fraction make sense? So if you have all positives less than 0, that doesn't make sense. If everything is positive and it's greater than 0, it always makes sense. So if we change that to a greater than 0, that would then be a true statement forever, and that would mean it would be the whole number line. So if you can't get a critical value at all, because this gave us no critical values, the answer is either going to be no solution or all real numbers, depending on if this statement makes sense. So that completes 2.6 and 2.7 completely, and I'm going to go ahead and post this right now.